Hey everybody, this is Coach Hammett coming to you from beautiful Georgetown, Texas here in room 122. Hope you're having a great evening. I know some of you are probably watching this at the track meet. Run fast, turn left. There we go. Let's jump in. 9-3 transformations. Basically, guys, what we're looking at is we're starting with parabolas, a normal parabola, and we're seeing how it changes in position based on the formula. Okay, so a lot of the stuff we've been doing is graphing. This is why it moves. Okay, what makes it move? All right, so we're going to start with this. F of x or y equals x squared plus k. All right, you can also think of it as plus c right there. I like c better than that because that's the last letter. Okay, if c is greater than 0, think about it. It goes up here. The y-intercept is going to be higher. If c is less than 0, it's going to drop down. Okay, this is the easiest one. All right, so you look at this graph and tell how they are related, how it translates. Translates means move. All right, so if this is our parent function, f of x equals x squared, how does this translate? It is translated 10 units up. Okay, so what we're going to say is it's translated 10 units up. It's moved up. Okay, so we're going to look right here. It's -8. So we know that this is our parent function. It drops down to -8 right there. G of x, remember, it can be f of x, g of x, q of x, whatever. It just means y. All right, I don't know why they write that in Mathanese like that. Okay, but that's what it means. It just translates down 8 units. Okay, all right. We're going to skip that one. I'm trying to breeze through this because I know y'all don't want a big long video on a Friday morning or Thursday night. Okay, to move it horizontally, you got to think about if it was graphed like this. All right, this is a perfect square. Remember, perfect squares are only going to have one solution. So if we start with a perfect square, x squared, okay, and we move it left or right, or I'm sorry, we start with the parent function, and we make h greater than 0, it goes to the right however many units h is. You look at the formula right here, and h is the number inside, okay? Now, if it is less than 0, all right, negative number, it's going to move to the left. Pretty easy, right? How many? The absolute value of that. They don't want to say h units because you can't move negative units that way. All right. So we look at this, x plus 1. All right. Now it's translated over. Whoa, 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 coach. What are you saying that it's plus 1 though? Why is it translated over that way? Because if you look at the formula, it's x minus h. So h would have to be, in this problem, h would have to be a -1. So it would be minus a -1 to make it a positive 1. Okay? Here's a hint. Take whatever sign it is and make it the other one. That's what direction it's going. Okay? So if it's positive, turn it into a negative, and it's going negative direction 1. All right? Blah, 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 blah. Right here, it's moved in a positive direction 4. So it's going to be -4, flip it, +4. Okay? Just works out that way. We'll do some graphing on this in class to show you what we're talking about. Now, what if we start messing with these things and get them to where they start moving in both directions? They move left, right, and up, down. Okay? That's where we're going to start having some big problems. Okay? And what you can see, I skipped it right here. Sorry, catching up. Describe how this graph is related to the parent function. Well, it's to the left one and it's up one. Okay? That's as easy as can be. To the left one, up one. All right? So it is translated there. This one right here, translated 2 units to the right, 6 units to the top, 6 units up. Be real careful about the scale factors right here. What the factors are that it's moving by. All right? Or the scale. Okay. Skip this. I think everybody knows it moves over 4 and down 2. Oh, down 2, it's only 1 square, but the y-axis is going by 2s. All right. Dilations. These are awesome because this is what we're starting with the blue one right here. That's your parent function. How do you make parabolas skinnier? How do you make them fatter? Okay? Well, if they're skinnier, the a value out in front is going to be greater than 1. All right? It's going to be greater than 1, meaning it's stretched vertically, straight up. All right? If it's between 1 and 0, all right, if the absolute value is between 0 and 1, then it's going to be compressed. It's going to be pushed down. All right, makes it more flat. And we've had some examples of this in class. So we've got 1/3 right here. What should that be? Well, let's think about what this says. If it's between 0 and 1, it's going to be compressed vertically. So let's look. And yeah, f of x is the green one right here, and the new one, d of x, is the flat one right there. Okay, so it's compressed vertically. All right, blah, blah, blah. All right, so right here, how does this graph relate to this one? Well, the 2 tells me that what? It's compressed, or it's stretched vertically, and it's moved up 1. All right, so there's all kinds of movement that we can do with these things. All right, how does 2x squared relate to x squared? Well, it's going to be stretched vertically. All right. How does 1/2 x squared minus 4 relate? Well, let's look at the 1/2. That's going to compress, and the -4 is going to move it down. Okay? So, what about this? What if we flip it? Okay, what if it's flipped? Then all that is, it's a negative a. It's a negative a value. Okay? So this one right here, it's -3x, so it's going to open down. It's +1. So let's see what the graph looks like. Here's our parent function. This is our new one. Okay? So it's reflected across the x-axis. All that reflected across the x-axis means is it's flipped over. Okay? It's opening down. It's stretched by a factor of 3, meaning it's stretched vertically, and it's translated up 1 unit. The vertex and the vertex moves up 1 unit right there. Okay? How does this one relate? Well, here's your parent function. It's compressed vertically, and it's down 7 units. All right? I can ask so many fun questions on this, guys. It's going to be awesome. Okay? All right. So there you go. Last one we're doing right here. How does g of x relate to f of x? Well, g of x is a -2. So it's going to be stretched vertically. It's going to be reflected, and it's going to be moved to the right 1. Holy smokes. So we're looking at A, reflected across the X, translated 1 unit left, vertically stretched right there. All right, guys, that's it. An 8-minute video. Sorry it took so long. Make sure you have your whisk done, and I will see you in class. Go, Eagles, go.